Right, so let's have a look. It's 1 AM and I'm kind of drinking some wine and messing about with my Arduino board. What a sad man I am. Anyway, I'm enjoying myself, so what the hell. Okay, it's been a while since my last video, but I quite like this little one. Another one based on a programming electronics tutorial and one of the little follow-on exercises that they do. It's basically taking analog input from a potentiometer and mapping it to pulse width modulation values and then controlling the dimming of two LEDs, and you can see it's inverted as you turn the potentiometer one way. One LED gets brighter and the other gets dimmer. I kind of like this one because there's some nice mapping going on and inversion of mapping. I'll take a quick look at the breadboard layout first off. So I guess so we've got a potentiometer here and we've got ground coming in on this side. I like my ground on the left so that I've got the 0 volts on the left and the 5 volts coming in on the right. So I'm a bit wobbly here. That'll be the wine. So yeah, basically 0 volts on that side, 5 volts there, and then the actual reading, the middle pin is going into A0. So that is basically taking in readings analog. It's going into analog pin, and all the way over to the right is going to be 1023. Analog values are 0 to 1023. Okay, and all the way over to the left it's a 0. So 0 to the left, 1023. As I said, 0 is basically where you've got ground connected to. Okay, the left on this one, and 1023 is where you've got 5 volts connected, and the reading comes from the slider on the middle pin, and that's going into A0. What I've also got, you'll notice, is on pin 9 and pin 12. I've just got a couple of LEDs connected through a couple of 220 ohm resistors into the positive legs, and then going into ground on that side, and then I've grounded it out slightly messily on that side. Lazy way, using a couple of alligator clips and a bit of tin foil to make a nice connection on one of them anyway. Yeah, so let's have a little look at the sketch anyway. So what have we got? Constant integer analog in pin is A0. Constant because it's not going to change, or it's not going to be allowed to change if it's a constant. So that's the middle pin of the potentiometer where the reading is coming from on A0 analog. So 0 to 1023. And the constant integer analog out pin on 9, although it's not really analog, it's pulse width modulation, which is basically digital pretending to be analog, but we'll talk about that more in a minute. And then analog pin 2, analog out pin 2, excuse me, on 11. Those are basically my LEDs, and pins 9 and 11 on the Arduino Uno are marked for pulse width modulation, which basically means they can mimic analog output through pulse width modulation, which is basically turning on and off at very rapid rates, 0 to 255. Anyway, what have we got? So we've got a sensor value, okay, declared but not initialized, okay, and that's going to basically be the analog read on the digital pin, which I'll show you in a minute. And then we've got an output value and output value 2. Output value is going to be pin 9, okay, and output value 2 is going to be an inverted value on pin 11 for LED 2. More of that in a minute. Okay, into the setup, fairly straightforward. I've got a serial begin, although I can actually comment that out. That was a hangover from the previous code. I don't really need to monitor this. I might just delete it. Let me get rid. Oops, did not lose me. opening curly bracket though. So what have we got? Yeah, just got a couple of pin modes then, setting both to output for both the LED pins. Okay, analog out pin 1 and 2. Okay, so 9, 11, basically my LEDs, set them to output. And the interesting bit, the loop, really kind of like this. So you're starting off fairly straightforward, sensor value. That's the value of the potentiometer, so that's an analog read on the analog in pin, which if you remember is A0. Okay, so that's going to come back with a reading of 0 to 1023, depending on where the potentiometer is at. If it's all the way to the left, because I've got ground connected left, it's going to be 0. And if it's all the way to the right, because I've got 5 volts connected right, it's going to be 1023. Now, here's the really clever bit that I like in this program. Output value, which I declared up here, but I didn't initialize. What I'm going to do is I'm going to use the map function to take the sensor value, which is basically my 0 to 1023 reading. Okay, so 0 to 1023, and I'm going to then map it to pulse width modulation of 0 to 255. And pulse width modulation is basically digital pretending to be analog. Digital you would expect to be kind of a 0 or a 1, basically, a high or a low or whatever. Pulse width modulation, as I said, it mimics analog by providing more values, 256 specifically, bearing in mind it's 0 indexed. Anyway, and then output tap value 2, which is going to be for my other LED. This is the bit that I kind of like. It uses the map function again, but instead of going from, you see here we've got 0 getting mapped to 0, 1023 getting mapped to 255. We've just inverted that here. So basically when the analog is 0, on this one it's going to be 0, so all the way to the left on the potentiometer here, this particular output value is going to be 0, but all the way to the left here it's going to be 255. All the way to the right on this one is going to be 255 fully on. On this one it's inverted, and 1023 is going to be mapped to 0, so it's basically an inversion of the pulse width modulation, and it works here because we've got 2 analog writes. First one goes to the analog out pin, which is my first pin. Okay, and that's just giving me the output value, which is mapped there, 0 to 255. But this one, going to the second pin, is taking that second value, which is inverted. Which basically means that, as you saw earlier, if I'm all the way to the left, okay, the LED on 11 is all the way right, 255. Okay, and then as we go, I'm heading over to 1023, which is getting back to 255 pulse width modulation, and the one on pin 9 is all the way bright. Very, very clever little inversion of the mapping from analog to pulse width modulation. There you go. Cool. As always, many, many thanks to programmingelectronics.com for that one, which was, as I said, it was a follow-on to one of their video tutorials, one of their challenges, and I just about managed to do it. I had a couple of little errors, but I got there in the end. Anyway, that's it. Cheers. Bye.